Thanks very much, and thank you, Liz, for chairing today so well, and to the LSE for putting on the workshop, and Catarina for writing such a wonderful book. It's been really nice to read it, and it's really fitting, I have to say, that the book has won the Lakatos Award because of how central Lakatosian ideas of dialogue in mathematics are to it. And in reading your book, it prompted sort of Lakatosian thoughts in me and took me back to my youth. So this is a little bit of an indulgent talk, where I'm going to tell you a bit about my development as a philosopher of maths. So I'm going to start with taking us back 30 years to the last century. I can't believe it's so long ago, but when I first went to university to do a degree in maths and philosophy, and how maths appeared to me then. It was a little bit like this, except it was blackboards rather than whiteboards. So we would go along to our maths lectures and be in a big room, and there was these rolling blackboards, and the lecturer's job was to write up the textbook on the board, and fill up all the boards, ideally by the end of the lecture. And our job as students, as it seemed to me, was to write down everything the lecturer wrote on the board, and we succeeded if we managed to write everything down. Of course, we wouldn't always write everything down, but ideally you'd have a friend who went with you, and ideally when you got bored, got tired of writing and ran out of time, they'd still be writing. After the notes, after the lecture, you'd sit down together and copy the bits that you'd missed from the other person's lecture notes. So that's what a maths education seemed to me to involve at that time, and it was a little bit odd. I don't know why we haven't thought of the idea of printing press and textbooks, and that instead the idea was that we would, as scribes, handwrite our own textbooks from which to learn. Of course, that wasn't the only element of maths education. We also had seminar groups where we would, or problems classes where we would work through problems, because of course we all knew that it wasn't enough just to write down the textbook. We also had to pass an exam on it, and so the problems class was teach us how to answer the questions that would be on the exam. So that was my maths education. And what the stuff on the board looked like, if we had a textbook, it would look something like this. There'd be axioms, definitions, lemmas, theorems, proofs, and so on. So we wrote our own nice textbooks, copying the lecture, with all of these results in. And so mathematics, as it seemed to me then, was a rather odd thing. And this is an absolutely true story, and I can't believe I asked this question, but as a first year undergraduate, we used to, after our problems classes, we used to go for a drink with our tutors and chat with them afterwards. And I remember saying to the maths teacher, well, is maths done then? Thinking that the job of the maths lecturer was obviously to tell us the theorems, and our job was to write down the theorems and be able to use them in an exam, but there was nothing else left. The results were there, and all that maths was about was learning this stuff and regurgitating it. And I was really surprised and amazed to learn that my maths lecturers were actually involved in proving things themselves, but it was bizarre to me how they might even do that, because these proofs that we'd seen took these ideas out of the air, used these concepts that were readily given, and I thought, oh well, these must be these genius people who are somehow able to pluck new ideas, new mathematical ideas out of the air and produce new bits of mathematics. So that's how it seemed to me as an undergraduate. But of course, as I was doing maths and philosophy, I didn't just get a wonderful education in mathematics. I also got to learn some logic and could reflect on the relation between maths and logic. So how did logic appear to me? Something like this. So my logic, as a maths and philosophy student, so it's fair to say actually that the logic education for people doing things like PPE was probably a bit better than this. There were some wonderful logic lectures given by the late, great Bill Newton-Smith. He did a wonderful job. But maths and philosophy students were felt to be above all that. This was too basic for us. So we were meant to do properly the elements of deductive logic and get back to basics. And that meant being in a small room with a smaller blackboard and a lecturer writing in very small writing that we could barely read. So we wrote down our notes. And the kinds of things that we were doing was this. Here's some axioms, derive some theorems from them. And so if you ask me then about the relation between maths and logic, I'd have said, yeah, they're pretty similar, really. You write down some things, you learn how to derive some other things. Maybe in maths, in logic, there was fewer definitions, perhaps, but they seem pretty close, and all of it fairly impenetrable. I had, thankfully, though, a really good logic tutor whose job was to not just, well, I felt his job was to help me pass the exam, but he felt his job was to try and make some of this understandable to us. And so he helped to kind of explain where these kind of ideas might have come from. And perhaps coincidentally, but perhaps not, this person was writing his PhD on Lakatos. And so somewhere along the way, I think he must have mentioned Lakatos to me. And I went away and found myself Proofs and Refutations. And reading Proofs and Refutations was an absolute revelation, because suddenly it wasn't mathematics presented as axioms, definitions, theorems, proof. It was, here's an idea, here's an attempt at proving it. Hold on, does this work? How about trying this? How about trying that? Is this step going to work? And the teacher saying, of course, I'm not sure. Of course, it might be wrong. And for me, this was a wonderful, eye-opening thing about how mathematics might be. Not how mathematics was as it was presented to me, but how mathematics might be. I never actually thought, from having looked at this, whether this has anything to do with logic and how logic is and how logic might be. And it's a really wonderful feature of Catarina's book that it really opens up that possibility of thinking, where once we might have thought the rules of logic are set in stone and given to us, actually no, they have a history, and they're developed through needs we have to persuade. So I really enjoyed revisiting Lakatos via Catarina's book and seeing how those same ideas of dialogue could be presented, not just to math, could be applied not just to mathematics, but to logic as well. But what I'd like to talk about today is not so much the dialogical roots of logic, but dialogue as it appears in mathematics, which relates to work I did a long time ago, but not as long ago as 1994. So having read Lakatos, I thought, wow, this must be right. I decided to carry on, not with mathematics, but with philosophy, and do a PhD in philosophy of maths. And I went to Toronto to do my PhD there. And the plan was, I'm going to show that Lakatos was right about mathematics. So, great, I'm going to go and spread the Lakatosian word and tell everyone how this is. So off I went to Toronto. And of course, in North American PhDs, you spent a little bit of time doing coursework. So I spent a couple of years doing coursework, but once that was done, I was like, right, now I'm going to give my Lakatosian account of mathematics. And I was all ready to go when I just happened to be chatting with a family member of mine who's a research scientist. He said, what are you going to write your PhD on? And I said, well, I'm going to give a Lakatosian account of mathematics, and this is showing it's all fallible, and it's all about proofs and refutations and this dialogue and so on. And he said, oh, right, what maths are you going to look at? And I thought, oh, perhaps he has a point there. I should actually look at some examples of mathematics to see, or to prove, I thought, to prove that this is what's really going on. So I thought, okay, I need to go and find out some maths. So I was very fortunate in Toronto that just before I got there, the Fields Institute had moved there. And it had lecture seminars going on all the time that were open to anyone within the university. So I thought, okay, I'm just going to go along to some of those. So after I went to the Fields Institute, picked a random course of seminars. It was seminars aimed at research students and postdocs, really, on a topic I knew nothing about. But it fitted with my timetable, otherwise I thought I'll just go along to those and see what I can find out. So I started showing up at these research seminars, and I was really lucky, I think, in that random choice I made, because the the mathematician giving those seminars, instead of axioms, theorems, proofs, he came in and just talked through a proof he was working on for the course of the seminars. So I was able to see classroom dialogue happening. In fact, a lot of it was dialogue between the mathematician and himself, sometimes the postdocs, and so on. But I was able to see a proof in action and the proof being developed. And what really interested me about this was that it didn't show me Lakatos was right. It didn't show me that Lakatos was wrong either. It showed me that there's more to dialogue in maths than Lakatos had picked up on. So in the dialogue in proofs and refutations, the prover skeptic dynamic is very much dramatized, right? We have the members of the proof given, and then the refutations given, and then the proof amended, and then the refutations, and so on. And Lakatos said, well, this is how maths is through proofs and refutations. And when I looked at this rather more ordinary case of mathematics in action, seeing a mathematician work his way through how to get to a proof, thinking about how he's going to prove something, I certainly did find dialogue, internal dialogue for the mathematician. Well, how about this with this work, and backwards and forwards, but it wasn't always between a prover and skeptic. And the reason why that was it wasn't always, for this example in this particular case, it wasn't clear what the hypothesis to be proved was. So what we had was a mathematician who had seen a previous published result, and he looked at that result and he thought, yeah, this is right, but I think I can do better than this. I think I can generalize it. I think I can get rid of some of the conditions on this proof, but I'm not quite sure how I'm going to generalize, how I'm going to get rid of those conditions. So there wasn't a bold hypothesis that he was putting forward and we were trying to refute. He would say, well, here's this proof that's been given, nothing wrong with this proof, except I think maybe we could develop it further. Maybe we could get rid of some of the things that the proof relied on, so as to get rid of some of the conditions. So it seemed to me that yes, there was a dialogue, there was even a dialogue that involved proof criticism of previous proofs, but it wasn't, how can I refute what this previous mathematician has done? It's, how can I do any better than this, and how might I do better? And the dialogue was trying to work out how a previous result could be improved. So that first seminar, I think it was 98 when I sat through that first seminar, and it did result in the mathematician George Eliot, who was publishing a result. Interestingly, the result he published, in my notes from that period, sometimes what he was trying to prove looked a bit like that, sometimes it looked a bit different, there were different conditions and so on, and it took coming up with the proof to get the result in the form that it gave. But it was very much a response to this previous proof. So what we have is a previous proof where you don't have to know all the details, but there's more conditions. And what my mathematician did was to think, okay, can I remove some of those steps in the proof and give a more general version of the result that gets rid of the conditions in the proof? I didn't just sit through one seminar course of this. I went back for the following year, and there was another proof attempt being developed, and other work being responded to. But again, it seemed to be very much along the same lines of, okay, I've got a proof idea that I think I'll be able to prove something in this area that works on previous work, but it was never a bold conjecture put up. It was more trying to work out what result I could convince someone of. So I wrote, when I wrote this up, what did I say? So the first thing I noted was this idea that yes, development in these areas of mathematics, this area of mathematics at least, involved dissatisfaction with published results, but not the thought that the results are wrong, but more the thought that the work could be improved, conditions could be got rid of and so on. And I also noticed that in the examples I looked at, far from there being a bold conjecture that then got modified by counterexamples and so on, the conjecture itself took time to emerge through the process of trying to prove something within a general area. And so the thought was, okay, well, I've got an idea that there's some generalization of this result that could be got, not quite sure what it's going to look like, and what became conditions on the theorem were developed as a result of thinking, okay, well, what do I need to prove something in this general domain? So we had what I call the co-development of theorems and proofs. So it's not that this wasn't about trying to convince people. The reasoning was very much about, well, what would I need to convince someone of something? But it wasn't very clear what the something was that we were trying to convince someone of, right? It was, what can I prove in this general vicinity? Given the hunch I have that there's something to be found here. Okay, so, I mean, that was just one example of one mathematician approaching some problems in the classification of seesaw algebras, as it was. So it doesn't prove very much, but I'm going to make some general claims anyway in relation to how these observations might fit with Catarina's picture of the role of dialogue in mathematics. So I'm going to agree with Catarina that it's really important to put dialogue as central in mathematics. But in the examples I saw, dialogue won't really prove a skeptic, at least in the context of discovering a theorem. We actually had discovering a combination of theorem and proof together, like what we discovered depending on what we were able to prove. So although I think the prove a skeptic model works well once you've got a theorem and you're trying to work out what you're going to need to meet the requirements of publishing something in the journal, even prior to that, there was a role for dialogue of a more open-ended sort involving constructive collective exploration of fairly open questions like, well, under what conditions can this technique be generalized? Can I remove these assumptions? Can I get rid of some of the more specifics of this particular proof to get something a bit better? And none of that really goes against, I think, anything Catarina says in the book. In fact, Catarina herself points out that there are dialogues in mathematics that don't take this proof a skeptic form. So looking at certainly the online mathematics community and how mathematical discussion leads to development of results there, Catarina points out, well, sometimes these are proof a skeptic, but very often not, right? Often it will be a request for help. And the dialogue will get going and structured mathematics will happen. So I think this is all in line with things Catarina has to say. And Catarina is, as she's mentioned today, in fact, is very much aware of what Wittgenstein calls the motley of mathematics, how there's a range of techniques and practices that make up mathematics as we know it. So it should not count as any problem for her view that my look at mathematics found a different kind of role for dialogue. What I'd like to suggest, though, is that if we follow Catarina's leading, starting from dialogue and noticing the importance of dialogue as a core part of mathematics, that actually allows us to think a little bit more about the range of mathematical practices there are by focusing on the range of different kinds of dialogues there are. So I think if we really want to understand the motley of mathematical practices that Wittgenstein talks about, then proof a skeptic dialogues are an important part of that. But looking at different forms of mathematical dialogue should be a really valuable way of understanding a little bit more of what happens behind the scenes between those axioms, theorems, proofs that I was presented back in the day. Thank you.